Good evening. Good evening. So we are on the next session of classical mechanics. In the first week, we have done all about Lagrangian and Hamiltonian. So today we will discuss all about Poisson bracket. And today's class is just about what is definition of Poisson bracket, what is property of Poisson bracket, and what is actually conjugate variables. And using this definition, we will try to go for some problems. But the actual use of Poisson bracket we will see into tomorrow's class, which will be tell about the time evolution of any physical quantity. And in tomorrow class, we will just discuss about the relationship between Hamiltonian and Poisson bracket. But before that, let's talk about what is Poisson bracket and how we can define this Poisson bracket. This is one type of mathematical formulation and which is very important for the classical mechanics. And this is also one of the important bridge between classical mechanics and quantum mechanics, or Newtonian mechanics and quantum mechanics. So this is wonderful mathematical formulation. So let's try to understand what are Poisson bracket. So suppose we have two function. Let's say the function is, first function is f1, and this is function of qi, pi, and t. So this f1 is written as a function of generalized coordinate, generalized momentum, and time. And what we have another function, and let's say this function is f2, and what will be, this will be also function of generalized coordinate, generalized momentum, and time. It may be function of generalized coordinate or momentum. So the symbol of written as f1, f2, this is identified as Poisson bracket. What is meaning of this Poisson bracket? So what is mathematically calculation of this Poisson bracket? This is just a symbol. This is just a symbol. The mathematical meaning of this Poisson bracket is something. We will go for summation over I del f1 upon del qi. The f1 is first, so we will go for qi, and then we will go for del f2 upon del pi minus del f1 upon del pi del f2 upon del qi. So this is meaning of Poisson bracket. If you want to open this Poisson bracket, this is the typical meaning. What is meaning about this? Suppose I have two generalized coordinate. Suppose I have two generalized coordinate. How it will going to open? It will going to open it. Suppose I is equal to, I have 1 and 2. Suppose we have two generalized coordinate. Then how it will going to open it? Then this will be del f1 upon del q1, del f2 upon del p1. P1 is the generalized momentum conjugate to q1. And here is del f1 del p1 into del f2 del q1. So first we have go for q1, and similarly we will go for next one, that will be q2. So this will be del f1 upon del q2 del f2 upon del p2 minus del f1 upon del p2 del f2 upon del q2. So this is, suppose I am running over two indexes, then you can go for this like summation. There is not any term of the cross term. You don't have any term. Suppose del f1 del q and del f2 del p2. This kind of situation is not there. First you will go for one generalized coordinate and corresponding momentum. You can go for another generalized coordinate and corresponding momentum. So this is just a mathematical definition of Poisson bracket. So if you have any doubt here, then you can ask me. Otherwise, we will go for properties of Poisson bracket. And this is very famously also known as commutation. So this is also known as commutation. So you can just ask me if you have any doubt. This is just a definition. And always, whenever you use the Poisson bracket, you will just write the thing in term of generalized coordinate, generalized momentum, and time. So then only you can just go for using the definition of Poisson bracket. You cannot have any other formulation. You have to write the function must be function of generalized coordinate, generalized momentum, and function of time. So this is all about Poisson bracket. So let's go for some property of Poisson bracket. So what is property? Suppose I have two function, let's say function A and function B. So we have these two function A and B. So we are just talking about the property actually. Properties of Poisson bracket. Okay. So this is A and B. Obviously, this is equal to minus B and A. So this is very trivial. You will write B first, A first, and this is not equal to B and A. So this is trivial. What will be next one? We have A plus B, and you are going to Poisson bracket plus with C. This is pretty simple. A and C, the Poisson bracket A and C, plus we will go for B and C. These all are very trivial. You can just derive it with yourself. There is no need to derivation. These are very trivial. The most important is A, B, and C. What will be this particular thing? A, B, and C. In the classical mechanics, order A, B, and BA can be interchanged. But I will suggest you that keep this order intact, because when we will go into quantum mechanics, we have the same definition. We have the same definition of this order. So I will suggest you that keep this order intact. Means what is meaning of order intacting? Means A is before B and B is after A. So I will just keep this thing in my mind. But classical mechanics, if you are doing AB is equal to BA, there is not any problem. But quantum mechanics, it is a severe problem. So why I am just going to write this thing such as we have A, C. I will write B afterward. After then what I have B and C, I will just go for A before B. So I have AB kind of ordering of this thing. So this is very interesting. I suggest someone is opening their video, please off that thing. Next, A, B, and C. This will be something equal to A, B. You can write C here. Then you have A, C. You will just be here. So this is very trivial. Suppose you have A, let's say lambda 1A and lambda 2B, where lambda 1 and lambda 2 are a scalar number, then you can just write lambda 1, lambda 2, AB, where lambda 1 and lambda 2 are a scalar. So you have to just remember this thing. So if you have A and some function of A, that will be 0. So this will be 0. And last is the Jacobi identity. So how you will use Jacobi identity? What we have, just make the rule. You have A, B, and C. What we are going to do? We are just starting with A, B, the Poisson bracket A, B, and C. So the first term you will write such that, and then you can go to the cyclic permutation. What will be next term? Next term will be BCA. So next term will be BCA. What will be next term? CAB. So you have CAB. And that must be equal to 0. That must be equal to 0. This is identified as Jacobi identity. Now in the examination, they will ask which one of the following is correct. What they will do, they will just change C to B and B to A. Then you have to first write this thing with yourself, understanding what will be your first term, and then you can do alternate plus and minus sign according to the situation. Suppose someone is given A, B, C, and suppose I can write this thing like that: A, B, C, and then I can write this will minus CBA plus I can write CAB. That will be equal to 0. So what you can do, you can adjust minus and plus sign, but this is the original form. This is the original form. So once you will write the original form, if anything will change, any order will going to change, you will just change A to B plus to minus. And suppose 2 time order is going to change, then you will change 2 time minus. So that will again plus. So you have to always keep in mind about how, and the rule is that the first term you will write directly and then make this cyclic permutation. And if you are moving in the clockwise direction, you will take the direction positive. So this kind of situation will be there. That there are some question in GATE that they will ask which one of the following is correct. Then you can just write accordingly. This is also Jacobi identity and this is also Jacobi identity. These two are equivalent because when I will change B to C, this will become to plus and this will be equivalent. So the sign convention is very important. The sign convention is if you are moving into clockwise direction, you will take positive sign. So if it is not visible, you can write just like that: A, B, C. You can move and you have this positive sign. So this is my sign convention. And once you are getting this sign, you can just go for this. So these are the property of Poisson bracket, and you have to remember this property. But the most important property are these two. So if you have any doubt, then you can ask me. Otherwise, we will directly go to some basic problem to understanding the definition of Poisson bracket.
Sir, if we write B before bracket, will it be different, right?
Sorry, where? This one. This one.
Ah.
No, in the classical mechanics, there is not any problem. Okay. In classical mechanics, there is not any problem. But what I suggest you, that make one rule always. Because in examination, it is very difficult to you that you will find which one is the classical and which one is the quantum sometime. Okay. Because finally you will see this all thing will come into quantum mechanics also. And in the quantum mechanics, the order is very important. So much better that you can remember the order. Otherwise, in a classical mechanics, the order is not important. Okay?
Okay, sir.
Even you will write CAB, this is not wrong in a classical mechanics. But I will suggest you just go with this thing. Okay? So let's try to go for some basic information. Then we will go for some basic problem of the Poisson bracket. Today we are just going to understand the definition, but tomorrow class is the actual physics. And yes, one question will always from this particular chapter, always. Now, let us go for this. What will be the Poisson bracket between x and px? So once we will write for this, then we will go for generalization of this kind of thing. So what is x px? You can just go for del x, del x, del px, del px minus del x, del px, del px upon del x. So what will happen? This is 1, this is 1, and this will be 0. So this will be 1. But if I will calculate what will happen, x and py, then this will be 0. You can just put it here. What will happen? Del x upon del x, and we have del py upon del x. Please mind it. This del py upon del px. This have to be del px because x is my generalized coordinate, and then minus del p del x upon del px del px upon del py upon del x. And similarly, if you go for y and z, then everything will be 0. So why this is not a conjugate variable? When you have this commutation, sometimes we use the word commutation. So whenever you have commutation and the Poisson bracket between canonical variable, then only it will exist to the 1. Otherwise, it will be always 0. So what we can do, we can generalize it. How we can generalize it? We can just go for qi and pj. This is Poisson bracket between qi and pj is identified as delta ij. What is delta ij? This is Kronecker delta, and this is equal to 1 if I is equal to j, equal to 0 if I is not equal to j. So this is will be always, so which quantity will there? So the only existence will be x px, this equal to 1, y py, this equal to 1. So this kind of situation is there. But what will happen? X py, that will be 0. What will happen? Y px, that will equal to 0. So these all things can be written in this form. And this is known as Kronecker delta. This is Kronecker delta. So you can write this is Kronecker delta. And this is definition of Kronecker delta. It will be either 1 or 0. So you can just go for problem by help of properties. You can just go for problem by just using the first principle, by the opening the Poisson bracket. It depends on which kind of situation is there, how fast you want to solve this problem. So let's start to doing some basic problems. Then we will try to go for next level of problems. Okay, so let's go for some basic problem. And they all are good problem actually. So what I am using, suppose I have Lz, it's some quantity, let's say this is z component of angular momentum, and this will be x py minus y px. So this is my Lz. What I want to calculate what will be x Lz, what will be Poisson bracket between x and Lz. So let's see how you can use the property. When you are going to use the property, what you have to do, you have to always concentrate on the conjugate variable. You have to collect the term of x px, y py, z pz, this kind of situation. So let's try to collect all these terms. So suppose if we are going to open it, then we have two terms, x xpy minus y px. And this is equivalent to actually x xpy. This is my first term, and second term will be x y px. Now if you are going to collect the term, now you have to go for ABC formula. Now you have x into x, sorry, x and x Poisson bracket, that is 0, x and py, that is also 0. So I can directly write this will be 0. Which term is going to survive here? X and y is going to 0. Which term is going to survive? Only x and px is going to survive. So this will be x and px. I can write y here. What will be x px? That will be 1. So this will be minus y into 1. So this will be minus y. So this value is equal to minus y. If you have any doubt, you can just ask me what I am going to do. I am just using the property. And what I am doing, I am just collecting the term. Which term is going to survive and which term is not going to survive in my mental calculation. So I just focus myself to x px kind of situation. So here there is, for first term, there is not any chance to be any term which will be x px. Here there is chance that will be x px will be there and y will be obviously outside and other will be surely 0 because x y will 0. So I think you can appreciate this particular calculation. So I am giving you just a 30-second, just calculate y lz. Then you can try to match it. Just calculate it, take your 30-second and try to calculate it by the same method. Just calculate and keep with yourself. I will just solve it. Then you can match. Okay. There is no need to respond. Okay. So let's try to calculate it. Again, we will go for the same thing. What we will get? We will get py. What is lz? Lz will be again x py minus y px. So very simply, I can write just one line again, py x py minus here py y px. This is comma. Obviously, in the first term, pyx 0, py 0. So this is not relevant for me. What will be second term? The second term will be py and y. Yes, it is going to survive because conjugate variable will going to survive. So this term I can write py and y. And what about px? This will just go outside. And another term will be py and px. That will be also 0. But what will be py and y? The pyy is equal to not 1. This is minus 1 because ypy is equal to 1. Please remember. So this will be minus into minus 1 into px is equal to px. So this will be answer. So this is your typical answer. So for the practice, I will just give you some homework. You can just find YLZ and you can find PXLZ. Just you can you can do this thing with yourself. Just using this all kind of situation. This is just a very basic. I am using very basic formula. So you can just go for this. Okay. Okay. So let's go for another problem. This is homework. You can just keep posting me after doing this thing. So now let's go for another problem, and it's a very important problem. We have mod R and mod P. Find the mod R and mod P, where R is xi plus yj plus zk, and P is a momentum vector, which is pxi, pyj, plus pzk. This is your momentum vector. So what we have to do, we have to just calculate mod r mod p. So what we need to do, we will just, so here we can just go for the first principle, because if there is some functional form, then we have to go for first principle, because then this thing is not going to work. So what is mod r? Obviously we know that mod r is equal to nothing, but we will go for x square, y square, z square. What will be mod p? Mod p is nothing but px square plus py square plus pz square. And now you can just go for this by using this particular thing. So we have mod r upon mod x, mod p upon mod px minus mod r mod px into mod p upon mod x. So this is the first term. And then you will go for y term. So again, we have y term del mod r upon del y del mod p upon del py minus del mod r upon del py del mod r upon del pz. Similarly, we can go for z term also.
Mod p, sir.
Sorry, this is mod, sorry, this will be y. Okay. So this p, there is p. So there is p. Okay, good. So we have small p. We have written this thing as a small p. Okay. So then don't worry. These are the p. Okay. So you can just, if you will change x to y, y to z, I to j, then there is not any problem. You can just calculate once and you can write it all again, same thing. Just like you will just change x to y. So what will be del mod r upon del x? So when we will go for mod r upon del x, you have 2x root under x square plus y square plus z square by 2. So this will cancel out into, similarly we have px upon x square, sorry, px upon px square plus py square plus pz square, and 2 is there, half is there. So this 2 is cancel out. The second term will be 0 there because it is not a function of x. So similarly, we can go for the y part as well as go for z part. That will be very symmetric kind of situation. So what will be this particular value? This value is y root under x square plus y square plus z square. And here is py root under px square plus py square pz square. So this will be plus time minus 0. And similarly, we have z upon root under x square plus y square plus z square pz upon root under pz square, sorry, px square py square pz square. So we can write it in a next form, and that will be, I can write xpx plus ypy plus zpz by, we have mod r mod p. And what will be this numerator term? This can be written as mod r and this can be mod p. Everywhere mod r mod p is there. So then the numerator is can be written as r dot p by mod r mod p. This will be r dot p mod r mod p. What will be this particular value? This particular value is r cap dot p cap, isn't it? So it is not necessarily always 1 or 0. Sorry, there is cos theta. This is unit vector. So in the option there is 1 also. So 1 will is not the answer. This is r cap dot p cap. Depends what will be direction of r cap and what will be direction of p cap and what will be angle between them. Then you can just write what is going to happen. So the correct answer is r cap dot p cap. 1 year it will be come into your examination and this will be a 5 marks question. So once you will understand the basic definition, you can easily calculate the thing. Once you know the basic definition, you can easily calculate the thing. So if you have any doubt, then you can ask me. This is just a mechanical work, just a mechanical work. So today's class is just a mechanical. Actual physics we will going to discuss on next class. So let's go for next problem. And this is again very nice problem. The Lagrangian of simple pendulum is given by the Lagrangian of simple pendulum is given by L is equal to half m L square theta dot plus, sorry, theta dot square plus mgl cos theta. We know this is the Lagrangian of simple pendulum. And for the given system, we have to calculate theta dot, we have to calculate the Poisson bracket, theta dot and Hamiltonian. We have to calculate, this is for theta dot and Hamiltonian. This is Lagrangian is given and you have to calculate theta dot as a Hamiltonian. And what is commutation between theta dot and Hamiltonian? So obviously it's a very interesting, because first we have to write the Hamiltonian. And how we will write the Hamiltonian? The Hamiltonian here is H is equal to, there is one generalized coordinate. So this will be P theta, theta dot minus Lagrangian. So this will be P theta, theta dot, and this will be half m L square theta dot square minus mgl cos theta. Now we have to replace this theta dot, that we are just doing the practice again for the Hamiltonian. What we have to do, we have to just replace this particular theta dot. So how you will replace it? You will replace it del L upon del theta dot is equal to P theta, and from here you have theta dot is equal to P theta upon ml square. So this is P theta upon ml square. So what we are going to do, we will just put it here. So when we are going to put it here, then this value is equal to P theta, and here is P theta upon ml square minus half ml square, and this value is equal to theta dot is again P theta upon ml square whole square minus mgl cos theta. This will be minus mgl cos theta. Then you can find the Hamiltonian, and this Hamiltonian can be written as, I think, P theta square upon 2ml square minus mgl cos theta. Now this Hamiltonian is written in term of theta and P theta, so there is not any problem. But here is theta dot. What I have to do this theta dot? How you will go for this information? You have to go for this information del theta dot upon del theta and del H upon del P theta. This is equivalent to, because theta and P theta is conjugate variable, and then we can go for del theta dot upon del P theta and del H upon del theta. Please don't make a blunder that theta dot and theta, this is obviously 0, but theta dot is function of P theta. Please, you have to see there. Theta dot is function of p theta. Remember here? So you have to remember all this formula from Lagrangian. So you have to replace this theta dot by something like p theta upon ml square and h. And obviously, then you can just replace it, and then you can write this value is equal to 0 minus del theta dot upon del p theta is equal to 1 upon ml square. And here we can put theta dot is equal to p theta upon ml square. Here also we have put theta dot is equal to p theta upon ml square. Or you can just go like this. So don't do the blunder into examination. Just p theta upon ml square upon del theta. And here is del h upon del p theta. And here is minus del p theta upon ml square upon del p theta and del h upon del theta. So this will be 0. I am 100% agreed. But this is not 0. This will be, the first term will be 1 upon ml square. And what is del h upon del theta? Del h upon del theta is cos theta, and it will give you minus minus plus. So this will be minus sine theta. So this will be minus mgl sine theta. So what will happen? This m and m is cancel, and an l is cancel. So what is value? The value is minus minus plus. So this will be g upon l sine theta. So this is the actual value, and this is very interesting problem. So if this type of problem will come, everything you have to calculate. You have to calculate first Lagrangian to this particular thing, and then you have to go for Hamiltonian, and then you can go for first principle and you can calculate this kind of situation. So this is a wonderful expression. If you have any doubt, you can just ask me.
सर ये माइनस जी बाई एल साइन थीटा नहीं आना चाहिए अगर डेल एच बाय डेल
क्यों आएगा बताओ बताओ. हाँ, डेल एच अपॉन डेल थीटा. तो डेल एच अपॉन डेल थीटा करो तो कॉस थीटा का क्या होगा? माइनस साइन थीटा. माइनस माइनस प्लस. Sorry. Okay. So this will be minus minus. Yes, minus sign will be there. This will be plus and this will be minus. Okay. Good. This will be minus g upon L sin theta. Yes. Good. Sorry. Because del h upon del theta is cos theta sin theta minus minus plus, and this minus will going to survive. Okay. Good. So this will be minus g upon L sin theta. You can check the calculation. Because I don't remember each and every and so finally you can just check yourself. But the process is very important. The process is you cannot just do the arbitrary, okay, ye to theta constant and then you can get 0, because first option will be given as a is equal to 0. So first option is 0. So this is not 0. You have to just understand the system. And is that this function is dependent of p theta or not? You have to check. Sometime this function can be function of theta as well as p theta both. You can check this kind of situation. So it's a very interesting kind of situation that you have to use this Poisson bracket. And why we are using that is not a concern for today's class. We will just use this thing just mechanically. Okay, this is Poisson bracket of definition and we are just going to calculate it. Okay, so let's go for next problem. Just for the practice, nothing else. Okay, so let's find let's find A dot R B dot P. Find the Poisson bracket between A dot R B dot P, where R is xi plus yj plus zk, and P is pxi plus pyj plus pyj plus pzk, and A and B, sorry, A and B are constant vector, are constant vectors. A and B are constant vectors. So obviously you can just go for the first principle, don't worry. How you can approach it? A dot R, I can assume, let us assume A is my some constant vector A1i plus A2j plus A3k, and similarly we have B, and B vector is something B1i B2j plus B3k. So I have this kind of situation. What will happen? I can assume A dot R is my function f1, and this will be something a1x plus a2y plus a3z, and similarly I have B dot P is equal to, let's say this function is f2, such that I can use f1 and f2 into calculation. So this function is f2, and what will be f2? B1 px plus B2 py plus B3 pz. Now you can go for this opening of this bracket. When you are going to opening of this bracket, del f1 upon del x, del f2 upon del y minus del f1, sorry, del px, del f1 upon del px, del f2 upon del x. So similarly, we will go for x, then we will go for y, because we have seen there is, once we will calculate one thing, another thing will be just a resemble like this. So del f1 upon del x is equal to a1, and del f2 upon del px is equal to b1, and this term will be 0. So similarly, this is for the x. What will be for the y? Y is equal to a2 b2 minus 0, and third will be, we have a3 b3 minus 0. So what we will get? We have this equation. This equation is a1 b1 plus a2 b2 plus a3 b3, and this value is equal to a dot b. That's it, isn't it? This value is, because we don't, we a1 b1 we have introduced from ourselves. In the problem it is given as a and b vector, so this can be written as a dot b. So this is a wonderful thing. You can just calculate it mechanically, don't worry. We are not doing any rocket science kind of situation. I am just talking about how things works, how the conjugate variable works, and this kind of situation is there. So let's try to go for one more.
Sir, can we do this problem by third property also?
Which property? You can do by any means. You can do by any means, don't worry. And which one is the third property?
Sir, where in AB comma C वाली property. मतलब कोई से ब्रैकेट में दो हमारे टर्म्स एक साथ मल्टीप्लाइड एंड द थर्ड.
आप जैसे भी कर लो, आंसर ये आना चाहिए. I am not bothering about this. Okay? Agreed or not? If you are more intelligent, you can do by using your brain also without any calculation. So
Okay.
I am not bothering about. Okay? But answer must be this. I believe in simple calculation because I am not so much intelligent person. Okay? I just want to go for the simple calculation. Okay? For example, suppose someone will give you x square, y square, px square, py square. What will be this value? Or you can just go for xy, yx. So obviously, if you can go with the property also, but if you will go into property, it will create a huge problem, because x square, then px square, then y, then lot of thing will be there. So directly you can just go for this. Take this one is f1 and take this one is f2 and just go for the first principle. Why unnecessary using your brain? It is very precious. We will just go for del f1 upon del x, del f2 upon del px minus del f1 upon del px del f2 upon del x. So this is x and y. Though we will, similarly we will go for del f1 upon del y, del f2 upon del py minus del f1 upon del py, del f2 upon del y. I have a straightforward this thing. If you want to go for the property, you can go for the property. Nothing to do. But why I am just wasting the, if it will work so simply, then it's a very simple. What will be this particular thing? This will be 2x y square. What will be this thing? 2 px py square. Then this term will be 0. And second term will be, you have, similarly, you have 2x square y. And then you have 2 px square py. So this and this term will be 0. So that will be 0. So this is just quite simple. You can take, what will be the common thing? You can take 2x, y, px, py as common. So here we have y, and here y and py, and plus this will be x and py. This kind of situation is there. So it will be
तो
finally
4
with in
कॉमन
which,
आएगा,
sorry
4xy कॉमन आएगा, 4xy
4xy 4x, okay 4xy, okay, good. 4xy is common, and then this can be answer. So I'm just giving you arbitrarily anything. You can just go for it and you can just calculate it. Don't worry. You can just go and calculate it. If you want to go with the property, you can go with the property. No one will restrict you. But why you will go into property if it will solve into one line? If you will go into the property here, then it will create lot of problem. Not problem actually, it will take more time. So if it is up to you that when you are going to use the property or not. Sometimes property is useful when things are linear or up to square term, not more than that. But otherwise, just go with the first principle. Yes, property will be much better if you have more and more combination kind of situation. So, but it will depends on you that how you can proceed this particular problem. Okay. So this is all about your different type of problems, how you can proceed and what you can use this thing. And now we can go for one or more problem again.
एक्सक्यूज मी सर,
हाँ,
सर जो आपने सबसे पहले एग्जांपल ली थी एक्स और एल जेड वाली, उसमें वो जनरलाइज कोऑर्डिनेट किसको देखना होता है? एल जेड
एक्स
में
वाई
जो है,
एक्स नहीं एक्स वाई जेड तीनों को देखना पड़ेगा आपको।
और जो एल जेड में
उसमें अरे तीनों को देखना पड़ेगा भाई, पूरे के लिए तीनों को देखना पड़ेगा। नहीं, तीनों को देखना पड़ेगा। आप फर्स्ट प्रिंसिपल से करोगे तो तीनों को देखना पड़ेगा। जो जो कॉम्बिनेशन है वो सारे कॉम्बिनेशन एक्स वाई जेड तीनों को देखना पड़ेगा, पी एक्स पी वाई पी जेड।
ओके सर।
नहीं, तीनों को अगर मैं ये दे दूं जेड और एल जेड दे देता तो ये भी दे सकता था, बट फॉर्चुनेटली दिस विल बी जीरो। व्हाई दिस विल बी जीरो? बिकॉज देयर इज नॉट एनी टर्म ऑफ जेड पी जेड टाइप ऑफ सिचुएशन। ओके ओके, एक क्वेश्चन लिखो। अ पार्टिकल is rotating on a ring, on a horizontal ring, just write a horizontal ring, on horizontal ring in XY plane, find P theta and L. So this will be, I think this is a homework for you, okay? So a particle is rotating on a horizontal ring on XY plane where P theta and L, where theta is generalized coordinate and P theta is generalized momentum. So this is your homework. Just try to do this thing. And let us assume this is your test. So this is, okay. So this is 2 marks test. Just do it right now. Just do it right now. Only 1 minute is there. 2 marks test. Leave the homework. Just do it right now. The ring of radius A. Take the radius A. Radius is radius of A. Radius A. Some ring is rotating something like this. A particle of mass m is rotating on this ring. This is radius A. This is in XY plane. This is your mass m. This is a horizontal plane. Okay. So there is not any gravity and anything else.
Sir, 0.
Zero. Pakka. Okay. Let's analyze yourself. What will be Lagrangian? The Lagrangian will be only kinetic energy. So that will be, you can write x dot square, y dot square. What will be degree of freedom? The degree of freedom, z is equal to 0 and x square plus y square is equal to a square. So there is 1 degree of freedom. I can just, there is not any potential energy. Just you can just change it. What I can put it into polar coordinate. So this will be half m a square theta dot square. This is my Lagrangian. Okay. So this is my Lagrangian. But when we are using this particular term, then what you have to do? You have to convert it into generalized momentum. So how you have to generalize momentum? Then generalized momentum is del L upon del theta dot is equal to P theta. Del L upon del theta dot is equal to P theta means ma square theta dot is equal to P theta. So what is theta dot? Theta dot is equal to P theta upon ml square. So if you are putting it here, sorry, ma square. So this will be ma square. So you have to write your Lagrangian in term of theta and P theta. So this will be, if you were put it, theta dot is equal to this thing, then this will be P theta square upon 2ma square. And now you can put it here. Obviously, the term will be, this is function of P theta, and this will be function of P theta square upon 2ma square. The term will be, both are function of theta. So the term will be 0. Both are function of theta, and this will be 0. Mathematically, you can write. And this is all about mathematics. So you cannot complain that this is the Lagrangian must be only function of generalized coordinate and generalized velocity. Yes, definition wise it is correct, but mathematically we can replace this thing by this particular thing. So once you will put it here, then you can get 0 answer. So in a homework, just you can find for this thing what will be happen, theta and Lagrangian. Okay, and you can also find theta and Hamiltonian. Don't worry. Obviously, here Lagrangian and Hamiltonian will be same thing. You can check. So just find this is as your homework. So this value is 0. So be very smart when you are using Poisson bracket. Always write each and everything into generalized coordinate and generalized momentum. This is the first concept. And second concept is where you are going for the first principle or you are going to the basic the property. So beware about this thing. Sometime property will work better, sometime first principle will work better. So you have to, whenever in a functional form is there, in if something F1 and F2 are in functional form, don't go into property, just go into first principle. But if they are in the linear forms out of this, then you can go for the property. Okay. So this is my experience. Otherwise, you can just better what you have to do in a calculation term. So I think I will stop here. So tomorrow is the very important class for using last two classes. So this is my last two classes, means the concept of Hamiltonian and the concept of Poisson bracket. We are going to merge it, and we have a very fundamental approach towards time evolution of any physical quantity. And this is the ultimate physics you can see in a classical mechanics. So tomorrow's class is one of the very important class. So before that, just go and revise at least last two classes. Okay. And then we will see how we can proceed. If you have any doubt, you can just ask me.
सर आपने जो क्वेश्चन कराया था जिसमें x स्क्वायर y स्क्वायर कॉमा px स्क्वायर py स्क्वायर का पॉइसन ब्रैकेट कैलकुलेट किया था, तो इसमें हमने जनरलाइज्ड कोऑर्डिनेट्स x और y लिए थे.
जेड ले लोगे तो सारा जीरो ही हो जाएगा.
नहीं,
उसको ऑब्वियसली जीरो कर दिया. हाँ.
सर अगर क्वेश्चन होगा सिर्फ x स्क्वायर कॉमा px स्क्वायर py स्क्वायर y स्क्वायर की टर्म नहीं होगी, तो हम सिर्फ x को जनरलाइज्ड कोऑर्डिनेट लेंगे.
सॉरी क्या बोल रहे हो, जरा एक बार मुझे बताओ.
सर अगर हमें कैलकुलेट करना हो पॉइसन ब्रैकेट ऑफ x स्क्वायर
हाँ
कॉमा px स्क्वायर py स्क्वायर.
नहीं, अरे यही तो है, px स्क्वायर py. अगेन यू विल गो फॉर x एंड y.
x एंड y बोथ.
यस.
तो सर जो हमने आगे क्वेश्चन किया था जिसमें हमने x py का पॉइसन ब्रैकेट निकाला था, उसमें हमने सिर्फ x को ही कंसीडर किया है, उसमें y को भी
नहीं. तो y वाला करोगे तो जीरो हो जाएगा, वो तो ट्रिवियल है. नहीं, y इज नॉट अ फंक्शन ऑफ x. ठीक है. आप ये कहना चाह रहे हो ना कि सर x px हमने किया था, इसलिए किया था कि दोनों x में था. एग्रीड. और आप इसको डेल x अपॉन डेल x फिर डेल py और फिर जब y वाला करोगे तो अपने आप जीरो हो जाएगा. नहीं होगा जीरो क्या? आप, मैं वो कैलकुलेशन थोड़ी है, वो तो भाई वो तो आपकी बेसिक. आप क्या कह रहे हो? मैं कह रहा हूँ x और px, इसको आप कर रहे हो, आप कर लो.
x एंड py.
हाँ भाई, x एंड py कर लो. डेल x डेल px डेल py डेल px माइनस डेल x डेल px डेल py डेल x, और फिर से y वाला भी करोगे, वो भी जीरो हो जाएगा इसी तरह से. वो तो देख के ही लग रहा है जीरो होगा. नहीं, ठीक है. ये तो बहुत ही सिंपल है, इसी कारण मैंने आगे किया नहीं. अदरवाइज आपको सारा, अगर दोनों में से जो भी है सारे का होगा, x भी है y भी जनरलाइज कोऑर्डिनेट. ठीक है. जैसे नेक्स्ट टर्म लिखोगे, अब y के टर्म में करोगे, वो भी जीरो हो जाएगा, x उसके साथ जीरो हो जाएगा, है ना. ओके. So I think I must leave this session. So tomorrow we will go for time evolution.